Now let's discuss the limitations of beam element approach in Caesar software. The first one is the Caesar uses the beam element approach to model and analyze piping system, which is efficient and widely applicable but comes with certain limitations. The first one is local stress analysis. It is not suitable for detailed local stress analysis like stress around nozzles or complex geometries, and it is also not suitable for analyzing local stresses at weld joints, nozzles or branch connections. So it means the local stresses beam element do not model the localized stresses like at sharp edges, nozzle and branch connections. Detailed stress analysis at these points often required finite element analysis, which is FEA. Secondly, weld and flange stresses. The stress concentration at the welds or flanges are not directly captured in Caesar software. For such cases, 3D finite element analysis FEA software like ANSYS or Abaqus is used. Second, simplified geometric representation. The straight and uniform members, the beam element assumes pipe is a straight and of uniform cross section, which can lead to inaccuracies when dealing with complex geometric like curved or tapered sections. Secondly, no local deformations. So local buckling, ovalization of the cross sections or dents are not captured in Caesar software due to this beam element approach. Third, the limited material behavior modeling. The elastic assumptions. The beam element approach in Caesar assumes linear elastic material behavior. Non-linear material behavior such as plasticity, creep or fatigue are not directly included. Second, temperature effects. While thermal expansion and stresses are considered, more complex temperature dependent material properties may be oversimplified. Fourth one is inadequate for dynamic and higher frequency loading. The dynamic analysis limitations. Beam elements are less accurate for high frequency vibration analysis or transient events like water hammer, damping and resonance. Similarly, the simplified damping model may not accurately represent the system's response to dynamic load. The boundary condition simplification. Sport modeling in Caesar. So sports are modeled as an ideal boundary conditions like fixed, sliding, which may not fully represent the actual flexibility or friction of the real sport. No soil structure interaction. For buried piping, the interaction with the surrounding soil is not accurately modeled. 6. Inaccuracy in complex loads. The first one is non-axial load. Beam element may oversimplify the effect of the loads not aligned with the pipe axis, such as torsion or localized impact forces. Secondly, the fluid dynamics effect. The pressure surge, pulsation or turbulence effect on the pipe structure are not fully modeled in Caesar. 7. Limited for higher nonlinear system, the beam element struggles with the system that exhibit large deformation, geometric non-linearities or significant load path changes during operation. 8. Lack of detailed results. Caesar 2 provides the global results like forces, moments, stresses, but detailed stress distribution or deformation pattern requires a more advanced FEA approach. However, to address these limitations, use complementary software. For detailed stress analysis at critical points, we must use FEA tools like ANSYS or Abaqus. Second, refine the model. Include the sufficient nodes and elements to get better representation of the geometry and loading condition. Third, apply stress intensification factors. Use code-based SIFs with stress intensification factors to approximate the effect of the localized stress concentration. Fourth one is conduct field validation, which is very important. Verify the Caesar results with real world measurement wherever possible. So let's start with Caesar interface. You can see this is the main menu of the Caesar software, where you can see the file, input, analysis, output, tools, diagnostics, ESL view helps. So this interface, it may be different because the software is developing every years, so latest software may have some additional features other than this what you can see on the screen. If you click on this icon, which is called the input piping icons, so when you will click that icon, this window will open, and this window is called the input window. Now we'll discuss one by one all the modules which is there in this window, one by one. How to input, how to create an element, what are the inputs required to generate a model, all these things will go one by one. So first one is we have to define the elements. So in this place where it's written from to 2, you have to define the node number like 5 to 10 or 10 to 20, 30, 40, like that. So for each element you have to define the number over here. It can comes automatically if you will give the gap between the two nodes equal to 10 in the settings. So it will automatically go to the next node from 10 to 20, 10, 20 to 30, like that. We have to define the length of the element, like in which direction element is going, in X direction, Y direction or Z direction. Here you can see the X direction, positive X, minus X, plus Y upward, minus Y downward, plus Z in this direction and minus Z in opposite direction. So this way these notations are there, or the coordinates are there. So whenever you have to give the length in X direction and positive X, so you have to define here. If it is in negative X, then you have to put minus 14, minus 20 meter, or minus whatever the value in X direction, then it will go in X direction, the element. Similarly in Y, if it is going up, plus Y, if it is going down, minus Y, plus Z, minus Z, like that. Third thing that we need to input is the dia of the pipe. Mean it's a 20 inch, 10 inch, 15, 16 inch, whatever is the dia of the pipe, you have to input over here. And then the wall thickness or schedule over here. Here we have to define the corrosion allowance. This mil tolerance is by default, it comes, so you don't need to change it. The corrosion allowance, if it is 1.5 mm, 3 mm, 6 mm, whatever it is as per the piping class, you have to input over here. Then insulation thickness. In this new version, now they have updated, they kept it somewhere here, the input insulation thickness. When I will go through the actual software, I will show you the insulation thickness they have shifted over here. But again, in this input generation, you have to input if there is any insulation, otherwise keep it blank. Then we have to define the temperature and pressures. T1, for example, we can take it design temperature. T2, we can take it as operating. T3, we can take it as design minimum, but you can define up to 9 temperatures. Similarly, pressure P1 design pressure, P2 operating pressure, and here is the hydro pressure you have to input in the value over here. Here you can see the bend, rigid, expansion joint, reducer, sieve. So whenever there is a bend in the pipe, you have to double click over here, so it will automatically generate the bend. If there is a T, you have to define here, click over here, it will define the sieve and the T. Sieve is again the stress intensification factor at the change in direction. Similarly, if there is a reducer inside, reducer is there in the piping layout, and you have to reduce the size, then you have to double click over here, it will reduce the size. So all these things will, and rigid is the one where whenever you have to define the flange or the valve, you have to click on the rigid, because flange, the software is considered a flange or a valve as a rigid element. So you have to click over here to define the flange or valve for the rigid element. So when we'll go through the practical example, I will explain and we'll model it in next part one by one in the Caesar software itself. Here in this location, you can see the icons are related to restraints, hanger, nozzles, displacements. So restraints, again the boundary condition like plus Y, guide, limit stop, anchor, whatever. So you have to click over here to define that. Hanger, you have to click over here, double click, and then the window will open, and you have to define and the hanger in the system. Similarly, if any displacement, like in case of tank, there is settlement, so if you have to put the displacement over there, so you have to click over here and put the displacement values. Similarly, in the nozzle, if any equipment, the piping is connected with any equipment and there is displacement in the nozzle from the equipment side, so you have to input over here in the nozzle, or nozzle evaluation, you can do it over here. but in latest version it is changed. So we'll see again in the practical example how to deal with this. Force and moments. If there is any forces or moments, we have to input any location. Uniform load is the seismic load if we have to define. So we have to click over here, then we can define, the window will open and we have to define over there the seismic values. Similarly, wind shape factor, if you click over here, the window will open and you have to define the wind shape factor over there. So all these things you have to input at the first element, and rest of the element it will automatically apply. Like uniform load, you have to apply only one time. Wind, you have to apply only one time. No need to apply again and again, no need. When you apply on first node, it will automatically apply on rest of the nodes. Then in this section you can see it will have like the piping material. We have to define this drop down window will be there. All the materials in the database of the Caesar is there, so you can choose any of the material with respect to your piping class, and click on that. It will come over here along with these properties. Automatically these properties will come. Poisson ratio, elastic modulus with respect to each temperature, H1, H2, H3. So it is already there in the database of the Caesar software. Then fluid density you can define over here. Fluid density, pipe density, insulation density, all these things you can define, input over here. So this bar you can see element, material, band, rigid. It will show you the summary or the list. How many bands are there in the model, how many rigids are there, how many expansion joints are there, how many elements are there. If you click one by one, it will give you the those values, and displacement, restraints, uniform load, where it is apply. So it will show you like a summary in this section. Here is this icon. Sometime this icon will be somewhere here, sometime is here, so you have to rearrange it. So when you click it, it will drop down arrow will come and it will show the individual elements lists. So these are the navigation key. If you have to go next element, you have to click here, previous element, last element, first element, like that. These are navigation key. For the new element, you have to click over here. This is for the new element. This is to split the element, this is to delete the element. So for after that 5 to 10 you have to go to next element, so you have to click over here at this location. So after input, so we have to perform the error check. When you will see the complete input is there, so what you have to do, you have to click on the icon. This is the icon where you have to click, and when you click the icon, it will run the error check and it will show you if there is any error in the model. It will show in the red color. Rest of the warnings it will show in green color. And here is the error summary. You can see how many errors are there, how many warnings are there, how many notes are there. So you can click and you can go directly to that. For example, if I click over here, it will directly go to that node in the 3D graphics, and it will show you the problems. And here is a description of the error, like bend angle on this node to this node is 97.95 degree. It must be between 5 to 95 degree. So it means we have to redefine it over there, or maybe the length is not sufficient, so that's why this error comes. Similarly, in the bottom, if you see classic input, and this is the error warning. So input and error warning mean you can go back to input, you can go to the warning. It will give you the details on the warning and the errors over here as well. The last thing is, if you want to close the window, you can close it from here. If you can like auto, then you can click over here. It will automatically close and open. When your icon will come over here, it will open it, and when the icon will be over here, it will close. So you can do it with these two navigation keys. So after the input, the model is there, and after the error checking is clear, everything is clear, then we have to define the loads.
When you will click on the icon shown on the screen, a new window will open. There you can add, or you can delete, or you can change the load cases that need to be evaluated for that stress analysis job.
You can see the load case editor, and I will explain one by one all these things, what is the meaning of WW plus HP, all these things.